In this video, we will continue our review of introductory probability, where we are calculating the probability of A and B, A or B, A and not B, etc., using Venn diagrams and two-way tables. And in this video, we'll probably even get to some word problems. Okay, so really everything you wanted to know about basic probability. So counselors look at 150 student schedules. The data is shown in this Venn diagram. B means these are students that are taking band. C, taking ceramics. And G, taking geometry. So band, ceramics, and geometry. One of these 150 students is selected at random. Use the information to find the following probabilities. So please remember, whenever I see the word probability, one phrase pops into my mind, and that is target over total. Because at its core, that's what probability is, target over total. So, probability of ceramics, probability of C. Well, we're told that the total is 150, so we can just start with that. So the target is ceramics. So here is the ceramic circle. So boom, ceramics. So if I add all those up, that's going to be, that's 27. So 27 over 150. And that reduces down to 9 out of 50. Okay, let's get ready to reset. Next, I need the probability of B or C or G. Well, B or C or G means all of any of these. So this is B or C or G. Okay, everything that I just highlighted is part of B or C or G. Or means you just highlight all of everything that is mentioned. So if I add all of those up, what am I going to get? Those numbers add up to 94. So I'm going to have 94 out of a total of 150. So 94 over 150, that's 47 over 75. Okay, I feel like I should reset for the next problem. Just erase all that. Okay, B and G. All right, that's just going to be the overlap between B and G. Okay, so that should be pretty easy. Here you see circle B, circle G. So the overlap between B and G is this portion right here. All right, so that is 17. So that's why we're going to have 17 out of 150. Okay. Events B and G are mutually, well, wait, hold on. Are events B and G mutually exclusive or overlapping? Explain your reasoning. B and G, well, visually we can see that they are overlapping because they are literally overlapping. There are the 15 and the 2 represent students who are both taking band and geometry at the same time. So conceptually, that's the part that we need to say. It is possible for a student to take band and geometry at the same time. So these are overlapping. Okay, moving on. There are 6 shapes below. 3 white triangles, 1 black triangle, 1 white square, and 1 black square. Okay, great. You randomly choose one of these shapes. What is the probability that you'll get a triangle or a black shape? Okay, or is more. So as soon as they say probability, you know we're doing target over total. So the total is going to be 6 because there's 6 shapes. So when you're doing or, that means you're just, you're just collecting all of the shapes that fit either description. So let's start with triangle. So we have a triangle here, 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 here. Now in addition to that, are there any shapes that are black? Yeah, there's one here. So everything I just highlighted is part of the target. All right, when you are doing or, you just highlight everything that is mentioned. So that's 5. So the probability is 5 out of 6. That doesn't even reduce. Okay, what else? You randomly, let me erase my highlighting so I can get ready to start over. You randomly choose one of these shapes. What is the probability that you'll get a triangle and a black shape? All right, we're still doing probability, so we're still doing total of 6, target over total. Now, when you're doing and, you're looking for the overlap between two things. So what I like to do when I'm doing an and problem is I highlight the first event in one color. So I'll highlight triangles in yellow, and I'll do the other event in blue. So I'll highlight any black shapes in blue. And then the overlap should be green. And the overlap is really that's what we're looking for. So let's start by highlighting any triangles. Okay, so we'll highlight triangles in yellow. So boom, here are my triangles, y'all. Triangle, 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 triangle. Okay, now I'm going to go back and highlight any black shapes. Well, my black shapes are here, and, well, hold on, this is supposed to be blue. So I can see the overlap will be green. All right, so I've got a black shape here, and I've got a black shape here. Where's the overlap? Where the overlap is the green. In other words, triangle and black, well, that's a black triangle. How many of those do you see? 1. We have 1 black triangle. So probability 1 out of 6. Okay, let me erase and reset. You choose 2 shapes, one after the other. With replacement, that means we're starting fresh each time. Find the probability that you'll get a white shape first and a black shape second. All right, so when you're doing 2 things in a row that you want both things to happen, you multiply. This is when you use the multiplication rule. So I need to find the probability of getting a white shape. So probability white first, and I'm going to multiply that times the probability of getting a black shape second. Okay, you multiply when you're doing 2 things in a row. So, the probability of white. Well, there's a total of 6, so target over total. How many white ones are there? 1, 2, 3, 4 white ones. So that's 4 out of 6. Next, we have the probability of black. Because we're doing replacement, with replacement means we put the first shape back. We started fresh, so we still have 6 shapes. Now, black shapes. How many black shapes are there? 2. All right, so that's 2 out of 6. So we just need to figure out what this is. Now, I'm going to reduce this. So 4 out of 6 reduces down to 2 out of 3. 2 over 6 reduces down to 1 out of 3. If I multiply those together, I'm going to get 2 out of 9. So that is the answer. Okay. If you didn't reduce, then you would have gotten 8 out of 36. So maybe I'll just put this off to the side. 8 out of 36. All right, those are equivalent. Now, you choose 2 shapes, one after the other, without replacement. So this time, when we pick the first shape, we're taking it away. And when I do this, I will scribble it out or cross it out to show that it is gone. So that's going to change the denominator for the second choice. So white shape, black shape. So it's the same thing over again. We're still doing the probability of getting white first, and we're still going to multiply that times the probability of getting black second. All right, the only thing that's changing is that this time it's without replacement. We're not putting it back. So the probability of pulling a white one first is still going to be 4 out of 6, because at the beginning we have all 6 shapes and there are 4 white ones. All right, but things change because we pulled a white one and we did not put it back. So let's imagine that this white one is gone now. So now it's time to try for the black one. There are 2 black objects, but now the total is only 5. So the probability for the second choice is going to be 2 out of 5. It was 2 out of 6 when we did replacement. It'll be 2 out of 5 if we don't put the first one back. So that's going to be 8 out of 30, which reduces down to 4 out of 15. Okay? You choose 2 shapes, one after the other, without replacement. So again, without replacement means that the second denominator will be less. Find the probability that you'll get a white shape both times. So this time I want the probability of white first times the probability of white second. Okay, let's just be real careful. So the probability of getting white first is the same as it was the last 2 problems. All right, we start off with 6 total objects. 4 of them are white, so that's 4 out of 6. Now let's be real careful about the second one, because again, we're doing without replacement, so things are going to change for the second draw. So again, we have drawn a white one first, a white triangle first. So, did it say white triangle? Okay, what's the probability of getting a white shape both times? Doesn't really matter which one it is. So if we drew a white shape, let's imagine it was this triangle. Now that's gone now. So now what's the probability of getting a white shape now? Well, not only is the total less because one white shape is gone, but our target is less. There are no longer 4 white shapes. Now there are only 3. So when we go to pull the second one, there are 3 white shapes out of a total of 5. So that's why this probability is going to be 3 out of 5, target over total. So this is going to be 12 over 30, which equals 6 over 15, which equals, all right, both of these are divisible by 3, so that's 2 out of 5. Okay, moving on. At Roswell High School, 65 teachers have a master's degree. 18 teachers teach math, and 12 of the math teachers have a master's degree. Okay, interesting. How many Roswell teachers teach math or have a master's degree? Okay, well, there are 3 formulas that we're working with, and here they are. So the first thing we have to decide is, are we going to be using the given formula, the and formula, or the or formula? Notice that the first formula is the only formula that mentions given anywhere in it. Notice that the addition rule is the only formula that mentions or in it. So, if the word problem says given, I know I'm going to use the first formula. If the word problem says or, I know I'm going to use this one. All of the formulas have and in it somewhere, so that doesn't help me too much. But if the word problem mentions neither given nor or, then it's probably going to be the multiplication rule. All right, that's kind of a nice little shortcut. Now this problem mentions or right there. How many Roswell teachers teach math or have a master's degree? Okay, so we are definitely going to use the addition rule because that's the only one that mentions or. All right, so I'm going to use the addition rule. But I'm going to make up new variables to fit the problem. So let's see. We have master's degree, 60 and master's degree, and then teaching math. Okay, that's a lot of M's. I think I will let M represent the master's degree. And I'll let T represent teaching math. Okay, so the OR rule will become like this. The probability of M or T is equal to the probability of M plus the probability of T minus the probability of M and T. So hopefully you can see that that's the same exact thing, but just instead of A and B, I have M and T everywhere. So now let's see what we have. 65 teachers have a master's degree. Now, technically, we don't know the total, so normally I like to set up a little target over total because these are probabilities. I don't know the totals, but I will show you a little trick. I'll show you why this does not matter. So what do we know? 65 teachers have a master's degree. Okay, that is M. Okay, having a master's degree is M. Now, normally I would do the total, so target over total. So I would do 65 over the total. I don't know what the total is, so I'm just going to put 65 over the total for right now. 18 teachers teach math. All right, that's the T event. So 18 teachers teach math. So again, target over total for probability. Normally I would do 18 over total. And you know, I would say what the total was. Or if this was a percent, I could put 100. Okay, now 12 of the math teachers have a master's degree. So this is a sneaky way of saying and. This is really an and statement. This is a sneaky way of saying that 12 teachers are math teachers and have a master's degree. They're sneaking it in without saying the word and. But if they say 12 math teachers have a master's degree, can you see that it's both at the same time? These are math teachers and they have a master's degree. So that's really an and situation here. And there's 12 of them. So that's the and happening. So I'm going to put minus 12, okay, again over the total. Now, whatever this probability is that we're trying to find, okay, how many teachers teach math or have a master's degree? That's M or T. Well, it would be this M or T over the total, right? All right, target over total. So here's the thing. Notice how all of these are over the total. So I've got this equation. They're all over the total. So guys, when the denominators are all the same, you can cancel those denominators out. I mean, technically what we're doing is we're multiplying both sides of the equation by the denominator. But the bottom line is if the denominators are all the same, the denominators cancel out. So that means it doesn't really matter that these are not fractions. We're going to have, all right, M or T is equal to 65 plus 18 minus 12. So we can just keep going from there. And in fact, there are no variables here, so we can just do this addition and subtraction. Okay, so we can really just go ahead and do 65 plus 18 minus 12. So that is 71. Okay, so this is going to be 71. Alright, so that is the number of people that teach math, that have a master's degree or teach math. 71 people. Alright, let's do one more problem. The probability that a student does chores is 0.68. Okay, so let's let C equal does chores. The probability that a student gets an allowance, given that he or she does chores, is 0.75. So I see getting allowance is another event. So we'll let A be gets allowance. Okay. Now, we see the word given in here. Right away, that tells us which one of these three formulas we're going to use. Alright, we're going to use the formula that has given in it. So let's go ahead and write that formula down. Alright, but instead of A and B, okay, we're saying the probability that a student gets an allowance given that he or she does chores. So we're talking about the probability of getting allowance given that chores are done. Okay, so now I'm just going to, instead of A and B, I'm going to put A and C. So I'm just going to write this formula, but I'll put C's where the B's are. So this is going to be the probability of A and C divided by the probability of C. Alright, that's just how the formula was. Now let's fill in what we know. All right, so I see the probability that a student does chores is 0.68. Okay, so that's the denominator. All right, so this is 0.68 right there. The probability that a student gets an allowance given that he or she does chores is 0.75. All right, this whole given thing is over here on the left. So this is your 0.75. Okay, find the probability that a randomly selected student does chores and gets an allowance. Okay, so does chores and gets an allowance. So that's the numerator, all right? We're looking for the probability of getting an allowance and doing chores. So that's the setup, and it's just a matter of solving this equation. So when you want to solve an equation like this, we're trying to get the numerator by itself. All you have to do is multiply both sides by the denominator. So I'm going to multiply by 0.68 on both sides. Okay, because that is going to cancel out the 0.68 and get this by itself. So all I really have to do is multiply these together. So that's going to be 0.68 times 0.75. Alright, so that's 0.51. Alright, so I've got 0.51 is equal to the probability of getting an allowance and doing your chores. Alright, and of course that's the same thing as 51%. Getting allowance and doing chores. Alright, so either one of these are acceptable answers. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.